let us proceed with our second subtopic of this chapter, that is electric field. In the subtopic of electric field, we're going to look at the definition of electric field. We're going to use the two equations for electric field, and we do the sketching for electric field strength diagram. This is our Earth, and this is a charge, negative charge. I hope you still remember chapter 8 last semester. Earth has its own gravitational field. So does the charge. Every charge will produce its own electric field. Electric field with symbol E is actually analogous to the gravitational field. The existence of the gravitational field of this Earth is proven when we bring a mass in this region. This mass will experience force. So force per unit mass is equal to gravitational field. For the charge, it is applying the same concept. The electric field is proven exists when we bring a test charge in this region, and this test charge will experience a force. The force per unit charge is equal to electric field. The previous explanation brings us to the proper definition of electric field strength, E. So it is equal to electric force per unit charge. The unit of force is Newton, and the unit of charge is Coulomb. Hence, we can have the SI unit for electric field is Newton per Coulomb. The electric field is represented by the electric field lines that is pointing in the direction of electric field vector. Now we have 2 point charges, positive and negative. If we bring a test charge to the region of electric field, this test charge will experience force. So in this case, for positive point charge, the test charge will experience repulsive force, so it will be acting in this direction. If we focus on the negative point charge, the test charge will be attracting to the negative sign of charge. So this positive test charge will be acting in this direction. In order to know the direction of electric field produced by these 2 point charges, positive and negative, that direction of force is taken to be the direction of electric field produced by the point charge. Then we have the outward direction of electric field for positive charge and the inward direction for electric field for the negative charge. In terms of the magnitude of electric field strength, apart from this basic equation, we can have a derived equation that is E is equal to F electrostatic force divided by the test charge. Then we can have E is equal to KQ over R squared. And this is how we draw the direction of electric field at certain point. So in this case, if we have positive point charge, the direction of electric field at this point is going to be to the right. So let's say we have another point here. To draw the direction of electric field, we have to start from, imagine we have outward direction of electric field. So electric field at this point is going to be this direction. For the negative point charge, as the direction of E is inward, so the direction of electric field at this point is going to be to the left. Okay, now we want to look at the direction of electric field at certain point. So we have a positive charge here. So what if I put a point around the region of electric field? So the arrow here is showing us the direction of electric field at that point. So it is always outward. So what if we move the point in the region of electric field? So you can see here the direction is changing. Okay, so if we put the point here, it is upward. If we put a point here, it's going to be downward at that point. And now we place the negative charge. So when we have a negative charge, the direction of electric field always inward. So if we bring closer, the point closer, you can see the strength of the electric field is bigger. So if I put this point here, it's going to be to the right. If I put here, it's going to be to the left. So that is how we determine or we draw the direction of electric fields at certain points. Let us do some example for sketching for electric field strength. So the question asks us to draw the direction of electric field at point P. So for number 1, point P is in the middle. We have charge number 1, charge number 2, and both are positive. So with respect to Q1, at point P, direction of electric field is going to be to the right because the direction of electric field is outward. And we label it as E1 because it is from charge number 1. For charge number 2, again the direction is outward because it is positive. So the direction of electric field produced by charge number 2 is to the left at point P. So this is how we sketch the electric field strength for case number 1. For number 2, again we have plus and plus. So it's going to be outward direction of electric field with respect to point P. So this is E1. With respect to point P due to charge number 2, this is how we draw the direction of electric field from charge number 2.